Now we'll revisit the introduction sequence and design an equivalent scene using the GameMaker object model. I'll show you how we can capture the scene dynamics using a simple finite state machine. We'll drive that machine with a custom markup language interpreted at runtime. Finally, we'll extract the introduction text from the binary in preparation for programming next time. Let's open the game up and run through the intro scene. We have a screen with a date text that fades in and then out when I push a button. Now we're on the planet screen that fades in, followed by text that fades in. Pushing a button fades the text out and a new line in. When the last text fades out, the entire screen then fades out. Next is the action credits sequence, which I admit we can't program up right now because we need a fully functioning gameplay engine first. We'll make a suitable placeholder screen for now that shows credit information. Now we have the skid destruction scene with the same text mechanics. And we'll wrap up with the explosion scene. All fading mechanics are the same, except now the text is centered on the screen, just like in the first blank screen showing the date. Let's draw out what we know in PowerPoint and see if we can find an overall structure. I'll make a new slide and call it Intro Flow. Let's start out broad and draw out the 4 or 5 screens that we saw. First there was the date, then the planet scene, then the action sequence, then the ship getting shot, and finally the explosion. Let's pick one of the scenes and expand it out. Let's use the planet setting screen. We start by fading in the screen, then the text fades in, then the program waits until the user hits a key, then the text fades out before another line fades in. We wait again for the user, then the text fades out, followed by the screen if that was the last line. This might seem like a random set of actions, but we can find a structure here if we draw a path through it as a set of states. I'll make a circle for each action state we've identified. And we've seen that the screen fade in always leads to a text fade in. Now if there's no screen or no text, then we can assume that the state immediately jumps to the next one. After the text fade in, we listen for user input, which leads to a text fading out. Now text out actually either goes back to the text fading in or to the screen fading out. And we won't draw that second arrow from the text out to text in because there's actually something else that happens before then. So far, I think we agree that everything in this chain captures the visible dynamics that must happen in order to traverse a single screen. Now let's talk about what we don't see. After every action, we have to read from our event script to determine what to do next. Now there could be another line of text to display, or we could have to change screens, or the scene may be finished entirely. We'll call that state read. And reading always happens after we've either faded out the text or we've faded out the screen. Now since we may end up reading multiple lines, we should separate out the reading action with the actual changes. Now this is very similar to the idea of back buffering in a graphics pipeline, except we're buffering action variables, not graphics. We call the implementation a swap because we're swapping the old set of display variables with a new set before going back to the display states. Now after a swap, we could either go to the new screen fade in or just a new line of text fade in if there's no screen change. We could either check where to go or we could simply force the next state to always be a screen fade in, which would jump immediately to text fade in if we're not changing the screens. But I think that showing the 2 exit arrows after the swap is more clear. We can see 2 possible loops to follow. The larger loop happens when we change entire screens, while the smaller loop just advances the text within the same screen. Now, a minor point from personal experience is that state machines should usually include some kind of state that suspends all activity. I'll put that here and call it sleep. For now, I'll make a bidirectional connection to the read state, since I foresee using this as a scripted event. If we wanted to implement a pause feature, then the object could jump to sleep from any other state. So we've laid the groundwork for an object that will implement this state machine. We'll call that object obj intro scene. It drives the introduction sequence. Now the object will depend on an event flow that's either hard-coded into the object or reads it from some other source like a file. In fact, let's make this interesting and commit to using an external file so we can make arbitrary changes to the scene without having to rely on rebuilding the game. Now that we have the concept down, let's get more specific. We'll start by itemizing the dynamics of the scene. Let's list the things that change throughout the scene because we'll need to assign one or more variables to hold the changes. Now, in fact, our read swap mechanic requires at least 2 variables for each idea, one for the current display and one for the next or upcoming display. Now let's talk about how we control the scene events. I said we'll rely on an external file. Well, that file needs to contain both the text to display as well as control sequences that describe the dynamics of the scene. Now, there are well-known ways to parse information like this, such as using XML or a JSON structure, but since this is a learning experience, let's just simply build the minimum case markup we'll need. Now, a basic markup operation needs a delimiting character, followed by some kind of operator signaling an operation, followed by a specific operand. Now, our delimiter could be an uncommon character. Angle brackets are common. So's the backslash. Let's pick something unusual like the regular bracket. Now we have to specify an operator that affects the dynamics we've identified up here. So the delimiter specifies control information. We'll then use a lowercase s to signify setting the screen. Now the operand that follows will say which screen. Let's use C to set the color, V to set the vertical alignment, H to set the horizontal alignment. Now I know we haven't talked about the action sequence placeholder yet, but to keep it interesting, I want to spawn a new object type that we'll discuss next. We'll use the O to do that. Now finally, we'll signify the end of the scene with E. A quick example would be setting the color of the text to say aqua. We'll use the following sequence: bracket C aqua. Now I admit this seems ugly, especially since many real-world solutions exist for handling key value pairs. Let's shape what we've put together so far into a GameMaker object. Now the object intro scene will have a create event. We'll have to register the object with the keyboard handler. Now we'll define the states, probably as an enum type. We'll need to set up the variables to include the data structure that holds the scene events. We'll also read that event script in from the file. We'll also need a step event that does the main work of the object, depending on the particular state we're in. Reading advances through the events and loads buffered variables. Swapping moves the variable values from inactive to active. Now the screen in and out simply fades the background. The text in and out fades the text. Listen handles keyboard input. Now, sleep does nothing really, but we may use it here in this case to activate other objects. And the draw event does just that. On destroy, we want to remove the keyboard and free all data structures. Now finally, we'll move to the next room, which is the main menu. Now we could call it quits for the design at this point, but I want to take a different approach for the placeholder of the action sequence. We're going to use that O markup command to transfer control from the intro scene object to a new object temporarily. And when that object is finished, it will transfer control back to the original object. Now, this pattern isn't strictly necessary because we could just use the intro scene object to load a new graphic and display credits. But I want to nail this pattern down now because it's going to come into play later when we want to generate arbitrary interstitial screens, such as during the dialogue sequence. We'll call the object credits, and its job will be to create a screen with unique behavior. Now in this case, we'll display credits and change the music. This can be done in GameMaker with 4 events, just like the intro scene object. On create, we'll register with the keyboard and initialize the variables and set the music. Now on step, we'll simply perform overall fading for the whole screen, probably by drawing a black rectangle over everything. Drawing is, well, drawing. When we destroy the object credits, we'll have to clean up the data structures, deregister the keyboard, change the music again, and transfer control back to the intro scene object. I think this design is sufficient for now. Let's change gears and pull the introduction text out of the binary. Let's figure out which binary we're dealing with. Now remember, the first sentence on the planet screen mentioned the planet's name as Seach. Let's search for that string among all the binary files in PowerShell. Okay, so it appears quite a few times. Up here at the top, we see the sentence that we're looking for from the introduction as part of file 000.exe. Let's make a new folder and file in our workspace. I'll call the folder Scenes and the file Intro Scene. Open the blank file up. Now let's open the binary file in IDA Pro. As it loads, we're looking for the intro strings under the string section. Now double click to find the string in the code, and we'll highlight each line and paste it into our intro scenes file. Now I want to keep each text group on the same line as it's displayed in the game. That should do it. Now in the next video, we'll build this intro scene in GameMaker, which will include adding all of our markup to this text file that we'll process at runtime.